Hello and welcome to another webinar session on Industry 4.0. Thank you for taking time from your busy schedule and joining the webinar today. My name is Abhishek and I am part of the marketing and sales team at Factana. So today's webinar is especially focusing on the role of Smart MES software in small and medium enterprises. So with a tiny introduction, I'll proceed with the webinar. So as an Industry 4.0 solution provider, Factana has been supporting very small and medium enterprises to adopt Industry 4.0 and digitalizing manufacturing solution. So we are a global company with operations in India, Europe, and USA. So Fogwing is our Industry 4.0 platform offering digital solution for IoT device management, asset performance management, and smart manufacturing. So this webinar will be presented by the founder and chief of Factana, Mr. Hariharan Ganesh. So without further ado, Hari, over to you.
Thank you, Abhishek. Hello, everyone. Thanks for watching this webinar or read it in our YouTube channel, wherever you are watching from. Hope you enjoy this presentation. So today the topic and agenda that we would like to talk is about MES system in the manufacturing organizations. And especially we wanted to talk about how the MES system will be fit for small and medium manufacturers. Generally, the systematic approach is followed by the large manufacturers with various level of skill of systems. But our focus is more, to address the system requirements for the small and medium enterprises or manufacturers who can adopt the digital technologies without heavy investment and technology knowledge and things like that. And today, then we are going to talk about how MES system is going to fit for small and medium manufacturer and why it is necessary for them to adopt a systematic approach or computerized approach in manufacturing production. Before we go into talk about MES and how that will fit into SME manufacturers, let's take a step back and talk about what is meant by manufacturing organization. To understand various different technologies, the buzzwords that are being in practice. So if you look at in the manufacturing organization, there are various level of operations are happening. From the bottom level, the production process or the physical process that creating the parts or the item that being produced by the machines, to the level of how the machines can be controlled with the help of sensors and controlling mechanism, and how do we make that controls automate the machine execution and process. From that layer to the top layer, the supervisory layer, where how the supervisor can monitor and control and operate multiple factory machines that being operated by the operator, but having a centralized view on that, on how they can aggregate the data and look at that holistically on the factory floor operations. Then the next level is on the operation management, which is more like the factory floor management aspect of that, how they can receive the manufacturing orders, how they can process the manufacturing order, how they can plan and execute different manufacturing orders at the different phases, different shift, different timing, and how they will allocate those orders into a different manufacturing unit, how the assembling line assembling together. So all of them is planned and executed. So the planning and execution is happening at the operations level, which is more on the factory floor level. Then the top layer, which is more like a top management, which involves the sales and marketing and financials team to have the holistic view of level of operations, right, from the holistically on the organization level. So if you take a look at that, the manufacturing, either you go from the top to bottom or bottom to top, it's all about how different layers are operating with the different responsibilities and ownership on that. If you look at from the from the systematic approach or the technology standpoint on the each layer, where you can see the sensing and layers are the production layers. The machine operations are controlled by the sensors and signals, right, generated by the machines, and those are controlled by the controlling unit, which is programmatically controlled, which is where the PLC systems are coming into picture, where the programmable logical controls are programmed to control the machines to operate in a certain frequency and waves and other things. The SCADA and HMI, the systems are the systems that helps at the supervisor level to control the machine operations and look at how the machines are overall operating across machines, across unit, across factory level, and how this data can be consolidated in a single human interface model to control the centralized control of that. So that's where the SCADA systems are coming into picture. Then the operational layer, which is more related to how the planning and execution happens. That's where the MES system, which is a topic for us today, the MES system or MOM system, either way is similar to that, and that being we are going to explore that. The top layer, of course, as everyone knows, that it's an ERP layer, which is the enterprise resource planning layer, which is more on financial and other things. So today we are going to see that how this is going to be. Our focus is more on the manufacturing operations, so which is more level to MES and ERP layer, which is where we are going to focus on that. And of course, many manufacturers are well equipped up to the SCADA level or monitoring and control level, but may not be equipped well with the MES systems as well. So that's the idea behind this webinar of how we can emphasize the importance of MES system in the manufacturing operations. So let's take a look at and know what is MES, because that's being the topic for the day. So let's understand it and what is meant by MES and how that is relevant to the manufacturing side of that. So MES stands out to be a manufacturing execution system, which helps to digitalize the manufacturing operations, especially the production floor operation, from the planning, execution, and tracking of the different activities happening within that, which involves in producing the products from the raw materials. So if you take a look at that, the raw materials, which in this case, for example, we take as the cycle, bicycle or bike, which we basically trying to assemble it. To assemble the bike or cycle bike, you as a production floor, right, we need the raw materials, right? So the raw materials includes the frame, the wheels, the handlebar, the seat, these chain models, gears, and other things, right? So those raw materials are going through the production processes, which is a multi-level process where it get assembled together. So that's where assembling is happening at a different scale, different level, depends upon different organization, different level of processes followed. So you can see that the production processes are how we assemble the cycle together. And once the process is field is processed, the finished products is coming out. In this whole model in the manufacturing execution, how do we plan and identify the list of raw materials required? How do we prepare the production planning? How do we schedule it? How do we execute the process in step by step? And how do we arrive the final finished product that can be stored, delivered to the customer as per the customer demands? So the entire factory floor operations are executed in a computerized way, in a streamlined way, with the help of the MES systems. So basically, MES system help us to operationalize the factory floor in a very structured way rather than the ad hoc approach that been in practice for quite long. So, but of course, manufacturers are very familiar with the MRP, ERP, and those systems. But let's take a look at how do we differentiate MES from other systems, right? So let's take a look at from the top down, right, which is basically the known thing is ERP system. So when you're coming to the ERP, like if you take SAP or Oracle or NetSuite or anything else, right? So any ERP systems, the scope of the ERP systems are, of course, it's dynamic at the to serve the top management and more business operational aspect of that than the factory floor operations. So it involves in financial calculations or financial processing, customer management, supply chain, human labor management, cost management, marketing, all those, sales processing. So all of them is part of the ERP because it is more intended for business operational aspect of that. When coming to the MRP, which is very specific to customized to the need of manufacturing companies, but at the same time, it is not as broader as ERP, but it is more streamlined towards the manufacturing companies' business operations, such as overall production planning, production scheduling, bill of material, sales, dispatches, orders, demand forecasting, and those kind of areas. It still sits in the manufacturing, the business operation layer that, as we have seen in the previous page, but it doesn't come down to the level at the factory floor level to operate on the factory floor execution standpoint. And that's where the missing piece of, how we will computerize or streamline or digitalize the factory floor operations and activities with the help of a system, which is where the MES system comes into picture. The MES system standpoint, as is intended for the factory floor operations, and it is intended to serve the factory floor executives or the plant managers and supervisors to address various planning and execution aspect of that. It requires a set of features and functions, and that's where the set of features and functions that will be provided by the MES system, such as from the production orders, machine controls, and materials requirement, material dispatching, receivables, bill of materials to execute the plan, structured way of producing the parts, and scheduling, and in order to tracking the production, right, in terms of how much, how different jobs are allocated, how different jobs are, completions, what is the overall completion of the production order, and what is the level of percentage of production order has been completed, and how the production are intended to complete it, and how long it's going to take to complete it. What is are we in plan with as per the schedule we are producing it, or are there any slow cycle in the factory floor level? So this required a lot of moving parts, and this required more comprehensive system to capture all the information, put together jointly, and look at overall visibility in terms of operational, factory floor operation, and that represents in the way of metrics and KPIs, how we will measure it. The KPIs such as OE and all needs to be prepared systematically rather than preparing an ad hoc manual approach. So MES playing a key role in the factory floor operations in terms of the execution than the MRP, ERP, which is more on satisfying the top management requirements. Of course, the context for the today is on how why MES is critical for the SME manufacturers, right? Especially SME manufacturers who intend to serve the top level manufacturers, to meet their demands, such as automotive manufacturers, or parts manufacturers, or different raw material manufacturers, or OE manufacturers. They're all the manufacturing companies, SME manufacturing companies, which serves to the larger enterprises through their production process. And of course, the challenge is heavy demand, dynamics of demand, different parts, different time. The priorities are keep changing, and also the impact of the supply chain challenges, which globally the manufacturing organization is going through today. And those challenges are also impacting the SMEs to meet the deadlines defined by the customer. So there are various challenges in the operation itself, but on top of that, the current working practice itself is creating additional burden to the and the SME manufacturers or the factory production operations aspect of that. So such as, some of the key points that we can discuss here on why it is very challenging for them, because of inadequate planning, because it's all odd hack based planning and scheduling. So suddenly some demands are increasing on a day-to-day basis, so they have to stop some production and switching to another production, and they don't know what is the impact of that, when that will be get delivered. The workload is not properly distributed across the machines and operators, so overloaded workload in a different timing, different zone. Sometimes shift 2 has a higher workload than the shift 1 execution. And because of the lack of planning and execution, why lack of planning and execution? Because lack of visibility in the production on what exactly is happening, because all of them are manually captured. The data is captured manually with the help of supervisors to make a note on the ledgers or papers, and they just trying to consolidate as a, they digitize with the help of the data entry operator to try to capture all of them. So it is all ad hoc approach happening on the floor on a day-to-day basis. Lack of visibility in the actual machine operations, how long the machine is operating, what kind of functionality, or how the machine is efficiently working. Those kind of informations are not immediately available, in the sense like it has to available within the day, within the hour, for them to take dynamic decisions in terms of prioritizing the production floor operations. And of course, that involves in manual collections, rejections, lack of visibility in rejections. Sometimes, rejections are counted end of the day, and then that rejections are more than they need to plan for next day again, rework, and that rework resulted in more time delays in terms of the customer delivery. And one particular work order delays are impacting other work orders due to the lack of sequential and planning. Sudden change in customer demands, and suddenly, with the lack of visibility in customer demand, and which is resulted in sudden change in the planning and execution within the day itself. And lack of visibility in stock when they're planning the production schedule for a period of week and month. Lack of material management, lack of stock visibility with other workload, other work order impacts are creating unnecessary overstocking, overbooked materials and supplies, which is basically stored in the warehouse without being used for a weeks, which resulted in cost of investment, right? So all of them are the challenges because of the lack of digital system in place to streamline this process and go by the systematic approach in executing the factory floor operations. To address that, we need the SMEs need a MES kind of a application systems. But generally, like ERP or MRP systems are a bigger systems, longer time to implement, and takes time to adapt into the organization. And that's very challenging for SMEs, because it may be affordable for large manufacturers, but SMEs cannot afford a longer period of implementation timeline to realize some value out of that, and of course the cost of the investment in the system. So this is where we are coming as a specialist to address this in a low cost, do it yourself approach, rather than doing it as a full blown ERP implementation kind of a timeline. So and our product platform that we designed with intention to serve the SMEs. So obviously we understand the challenges in the SME market, SME field. So we wanted to address it. We want that to be adopted by them. So we made it as simple as that for them to capture the data uniformly and do that. And all systematic is structured in a way that it can be easily understandable by them by the simple data entry operator or supervisor to capture the data and then use those data for that. At the same time, giving them visibility to the top management. So in the SFactrix as a smart manufacturing MES system or MOM system, which also includes operational metrics inside the product itself, which helps to capture the factory floor operations. The SFactrix role is purely on the MES side of that. Even though there are some overlapping functionalities are there in the ERP or MRP standpoint, but truly our intention is to serve on the factory floor operational aspect of that. So the SFactrix as a product provides different functionalities from the work order management to the factory floor management, which is what we are going to see it in our session today. So what are the functionalities, right? So when we categorizing our functionalities, we are identifying it in a set of 5 groups. So as operational groups, one is the plant organization, our factory organization structure, defining it, how well we define the factory organization, and that well accuracy of data will be produced by the system and metrics. So it's very important to properly structure the organization, and how that should be created, like a plant organization, the work center, the shift hours, and the machine availability time, the machine productivity time, and then this the cycle time, the ideal cycle time of the machine. So those kind of things we need to configure properly. So that's a plant structured plan organization. That's a fundamental for before we get into the MES execution aspect of that. The next one is on operational master data, which are more like the parts that being produced by the manufacturing, or the product that being produced by the manufacturer, and the raw materials required to produce a product, the bill of material configuration, how well structured the part and manufacturer help us to schedule the execution uniformly, as so the bill of material is critical for creating a proper scheduling and planning. Then production execution, in terms of the day-to-day executions, how to capture the work orders, how to break the work order into multiple jobs, how do we assign the jobs to different operators, how we can capture the data from those operators and the machines uniformly, so that we know that we can consolidate all the data together to come up with the proper visibility and tracking of the current floor operations, and capturing the quality of work being produced by the machine and operator, by capturing the good quality, rejections, and rework all stuff. Finally, manufacturing operations requires efficient machine management, machine maintenance. So it's not a separate process. It is bundled with it is part of the manufacturing execution itself. So we have added the machine maintenance as part of the system itself, to capture by the operator itself if they are facing any challenges with the machines, in terms of the different faults happening in the machines. They can report it, and that can be addressed, and also the preventive maintenance aspect of that. So all of the functions are captured, on all the data are consolidated together to arrive the meaningful tracking and visibility and metrics, or KPIs, for the manufacturing plant managers or the supervisors to execute the day uniformly, or execute the task in the day uniformly. So far, we wanted to make sure that this particular session, we are having a blend of how theoretically we need MES system, and then practically how we can execute that, how simple it is to execute that in our system. So let's take a look at on the demo, or kind of going back and forth between the to the system. As a first step, what we are going to do that, right? So maybe I will go back to the presentation. So what is the first step we are going to do that is, how to get started with that, right? How to get started with this particular system. It's a do-it-yourself. You don't need any IT expertise to do the work. You just simply create account, subscribe to the account. It's just a 2 minutes work to subscribe to the account. There is no credit card required. There is no contract required. So any small manufacturers or mid-sized manufacturers can themselves go and create an account without us involving on that. But first step is, as we looked at that, setting up the organization structure is very important to create a proper execution plan and execution metrics uniformly from the system. So as part of the organization setup, right? So there are 8 key elements, or 8 key modules that needs to be created from the top-down approach aspect of that. So start with the plant, setting up the whole plant. What is my mean by plant here? Because this system will support to capture the data from multiple plants in a single system. You can create a number of plants, and each plant can have its own work centers or workplace and missions, and each one can be consolidated, and as organization, large manufacturing execution or mid-sized manufacturer can also capture data from all different plants in a single system, and uniformly the top management can look at how the production floor operations are happening. So it can be scalable to multiple plants or single plant. It depends upon the organization structure or organization, how they put together. And creating work centers, assets are the critical pieces, because this is where you need to configure different set of basic information, then defining your product or part, and of course materials and supplies all together. So let's take a look at how this is going to be. So once you created the account, you go to our product. As soon as you created account, you land in the dashboard as the account admin. So you are not a plan manager or anybody else. You are creating an account, so you land as an account admin. In the account admin view aspect, they can see that what are the different overall structure of the organization here. So you can see here, I have in this account that I have using for my play account, so where you can see 5 plans, 6 work centers, 6 assets declared, and different work orders and things that are created. So what you need to do that, as a first step, you have to go to the settings, and you need to start creating your plant work center assets. So creating plant is a simple step. If you go to the plant, and you can just click add and create your plant. I'm not going to do all of them today now, because this webinar is scheduled in a shorter time span. So I'm going to show it on more executions, but I'm just going to walk through this on what are different things are there. So you can create a plant. I have created a number of plants here. You can create a plant. There is no restriction here. Either small manufacturer or large manufacturer, whether you are in a contract with us or not, you are a paid customer or not, you can create a number of plant work centers. So you need to define the plant. When you're creating a plant, obviously you will know that how many work centers you wanted to, or workplaces you want to create within that. So once you created the plant, then you need to go to work centers. When you add a work centers, obviously you select the plant, which plant for which you need to create a work centers, and you also have a shift hours. So let me take a show you one of the work center unit. So you can see here, yeah, you can see here this work centers. It is under the plant, and then it has time zones. Also, you can see here we are capturing different shift hours here. So you can capture up to four shift hours based on your operating model, declare which dates your production operation. This is very important piece on the shift hours, because all your efficiency calculations are based on the shift hours and the working time zone. So it is critical to capture it. So you can declare that. Once you declare that, then you can go and add assets. So assets are your missions that you operate. Here in our system, everything is based on the missions. Even if you are using a smaller tool for your production operation, and you want to know that how efficiently that particular tool is being used, you can still create that as an asset, and then you can capture that particular work efficiency of the tool itself. Either larger machine or smaller tools, you can declare it as an asset here. When you declare it as asset, you can see here the status and all stopped, one of the machine is running. So you can clearly see here itself on how the assets are operating. The other way, you can also see it in a table view, where you can see this particular asset is running, all others are stopped. You can also see here, what is the run rate of the asset, how long the asset is available, all of them. So you can simply creating asset and define your asset as part of that. While creating it, make sure you put a lifetime, maintenance frequency, ideal run rate, because these are all critical field for us to capture the efficiency of the machines that being operated in that. This is more important for the OE calculation standpoint. Once you are created that, then you go to the part management as well. Parts are nothing but the product that you are creating. Here, the beauty of this particular functionality is, how do you capture the parent and child part? You may create smaller parts that you may directly sell it. You may also create a full-blown product that you are selling it. Either you are selling as a full-blown product, or you're selling as a part. either whatever structure that your organization, you can create it as a parent part or child part, and depends on that you can define it. Also, you can manage the stock here. As and when you execute the production executions, the production completion, the number of good quantity production, minus the rejections, that resulted in stock improvement here. So as a result, you can on the fly, as the production is happening, you know that what is our quantity production in a particular. You can go with the order based model also. If you are make to order kind of manufacturing setup, and you are getting customer order, and each product you are specifically creating for a customer, you can define those products, and then you can track how much that particular product work item is being created in a particular day and a particular time period also. So you can also define your cycle time here. Each product cycle time based it producing the efficiency of the production, and we capture that based on that. Of course, you also have a process to say that whether you are making a production in a sequential or parallel process aspect of that. So you declare all of them here. The most important piece here is the bill of material. So when bill of material is based on the material and parts. So let's take a look at a bill of material, right? Bill of material is the most important piece that we recently introduced, where you can go and create a BOM with set of materials required. To make one product, you may need set of materials required. That includes a child part as well as the raw materials that you want to combine together. And to make that production, you need a set of processes. So here you can declare it. So let's take a look at that one of the process. I'll take it for a quick view. Okay, so this particular one. So you can see here this bill of material. The production cost is 100 for making this particular part item, which is basically a particular tube type. To make it as the cost is 100. How the cost has arrived based on the materials required and the process required. So you can keep adding your materials. Let's take, to make this product, I need another material. Okay, I have this particular one child. Otherwise, I'll go on and clean it up. Then I'll go here, add one material. And then I'm saying that this material is required for 5 quantities. Add a material here that get added as a material. So you have a part, child part and materials together is your material requirement to make one parent product. Then once you created this, then you can go ahead and create a process. In the process, you can select the part that child part that you are creating it. And you have a lot of types here. You have different stages in your process, either your preparation, production, assembling, all together, right? So you can select, let's take, I'm making production. Number of quantities are 5 that I'm going to make it. My labor cost is, let's take, 10, which based on how you declare in the organization level, whether you are in dollar, euros, on what basis you are calculating. And that way, your cost is coming. You can see here the cost has stood up into 600 based on the quantity required and the cost of the product and the process together. So you can create, this is a very simple process, right? You may have n number of things, same parts. After production, you are doing assembling, same 5 quantities, labor cost is 1, and you can add it. So you can keep adding the production, assembling, and things like that. How many processes you are following, you can define it as part of your BOM, bill of material. So once you are done with that, then your whole organization setup is completed. Now, next step is the execution step, and this is where our product is come to picture. So let's go back to the one and talk about production execution. So production execution or execution of the manufacturing, factory floor execution requires a set of things, right? So you may have a manufacturing order or work order, which is kind of creating a cycle, right? Basically making a bicycle or bike that you are making it, which require n number of set of subset of work orders, right? Or subset of process or production task that should be executed to make one full product, right? So for that, we breaking that into two level. One is a manufacturing order, is also called here as a work order, and then you could break down the work order into smaller set of tasks, and those are all called as jobs. So you basically allocate the jobs to the operator. So each machine getting different jobs to create one product or many different products, depends upon how your organization is structured. So work order and job execution is the critical here, and that should be tracked on a day-to-day basis. And then how you define that. So let's, and then other things like, you set it up, maintenance frequency and the rules and other things and all, additional functionality that you get as part of the production execution. So let's go back to the system. So as simple as that, you come back to the dashboard. So now as a first step, I'm going to have a work orders. So I get a work orders. You can integrate this with system, or you can import it using the batch process. So if you already have a ERP system where you create a work order and you want that work order to be sent to the factory floor for them to operate it, you can get the work order here. So work order creation is simple. You can see here, I have n number of work orders here, and you can also see here the status of the work orders. Some of the work orders are already completed. One of them is pending and one of them is in progress. And you can see here customer, product, which product is making, what's the order quantity, duration, all of that. So you can, from here in the simple view itself, you can see here how my productivity, what is my current status of the work orders. These work orders are in progress, status, or progress are coming based on how the subsequent jobs are executing within that. So you create a work order. So you basically go and create a work order. Let me take a quick look at one of the work order that I created it already. So where you can see here the work order is being created for a customer, for a particular plant level allocated, the priority on that, and then what is the estimated time to complete it based on the cycle time. It's automatically calculating it, the batch, lot, and other sales order references. All of them, you can feed it or you can import it. As I said, you can also import it. But if you want to create it as a small manufacturer, you may not have a ERP, but you can use this system itself as one of the source for you to create a work order based on your customer orders, and then start capturing it. If you are a mid-size and large manufacturer and you already have a ERP system, you have option. You can use a batch process that we have the feature in the backend side, using which you can import or integrate with your system such as SAP. If you're already using SAP, you can integrate with the system through our implementation team, that they will help you to customize it and implement it. And then you can get the data, feed into that automatically into the MES system that we have created it. And our system is in the cloud. So everything is in the cloud. So you can easily, anytime you can access the data. So once you created the work order, then you go to the job. So you need to create a jobs for those work orders, which also can be automated with the help of BOM. As we saw that the bill of material will help you to structure the production, structure the work order and job creation. So based on your selections, you can automate. You can also automatically create it by using the process. But if you are more like you want to manually have a control on jobs, you want to allocate jobs, you can create a jobs. You need to select the plant and work centers, assets, which asset you want assigned to the particular job, and then you can select a job type. This all filled by the process. If you're going with the BOM, the job code, let's take I have a job code of 5x5, and then the work center is work order is this one. So like let's take part cycle time is 10. You can declare cycle time at the part level, as well as you can declare that in the task level. Depends upon how you wanted to capture it, how you wanted to finish it out. So you create it, and then automatically it's create a job. So as soon as you created the job, you can see here the order quantity is 100, but it is yet to start, right? So this is simply as simple as that. You can create it. You can also look at in the table view, so you know that what is completed, what is progress, what is expired jobs. And also you can allocate these jobs to the operators. You may, by default, when you're creating a job, this job is allocated to all of them, or you may go and select the operator. Operator, and you can select, let's take in the Thomas is operator. Thomas is operator, and then you can allocate that to the Thomas. Or if you say that no assignee, you basically create a job and work orders for a week, for a month. If you are a continuous manufacturer, make to stock manufacturer, you want to continuously produce it and stocking it based on the demand. So you can also do that as a longer work order, longer jobs, and that way the jobs will continuously executing. While you are creating it, you may not know to whom this particular job can be assigned on so and so date, so you may just select it and say that this job need not be assigned to anyone, so this job will not be assigned to anyone, so no operator will see this job at all. So this kind of a job execution allocation can be done. Once the job operators receive the jobs, what they will do that is they have to go and operate in the system. So to see that how the operations can be controlled, so we have job controls. The controls help you to this is similar to the SCADA system controls, but if you are using our integration with the IoT integration, then everything is streamlined. If you are not funded to use IoT technologies, but you still want to start with simple execution system without using IoT technology and connecting with your machines, you can still use it instead of using Excel sheet or any other paper-based data capturing model. You can use this system to capture it. So what all you have to do that is select a job and pick the job that you want to start. Let's take, I created this job recently, right? So this particular job is running in this particular mission. The mission is already running. So fantastic. You can also control the mission status here, and then you can start producing it. Let's take, I'm producing it 3 quantity here now. So you start producing it. You can, end of the day, you can also enter it. Let's take, you not be always entering here. You may enter it in a hourly basis. You may enter it in a periodic basis, or maybe end of the shift you want to enter the data. You can still enter the data so that you get the data captured on that. So once you created the quantity, you can keep as the quantities are getting produced. Let's take, I have produced now 1 quantity produced. I have produced another 5 quantities. So based on your quantity production, you can continue to report it. At the same time, you also have a control to report the resistance. Let's take, out of 5, you see that 8 units I created it or produced it, but I found 1 defect on that. So, and the reason for the defect, these are all really helpful for you. So I'm saying that crack is the reason. So once you are done with that, you go back to your work orders and your jobs. You can see your job is already started working. See this job that is created recently, and job is in progress. 7 quantities produced, 1 rejections. It's already started showing 7% in progress. So at real time, the visibility is there when the operator operating the machine and they get the data and feed the data to the systems, either manually or through automation through IoT. The data gets populated here, and that data are showing you that track traceability. So when your plant manager sign in and they look at this data, and our supervisor sign in and looking at this data, they exactly know that at every time the data gets fed into the system, they exactly know that what is happening in the production floor, how many jobs are being executed, each and every work order, how much is production is completed, all of that. If you go back to the dashboard, right, so you can see here all the asset status, other things. I can show this in a metrics standpoint. Let's go to the metrics, where you can see here, the OE metrics is already producing as of today. The performance is there. So machine is available 100% as always being running based on the production quantities, right? The quality is 94%. Performance is 5% because I just started producing the data in the system, even though the machine was running a longer time. So based on that, your machine efficiency, duration, availability, all the stuff, you can calculate. Also, you can see here the slow cycles. Of course, the numbers are different because of this my test data, but you can efficiently see that what is your efficiency level, your slow cycle period, your number of quantity produced by this machine on a day, on a number of rejection happen on the whole day. Even though it's multiple jobs, multiple things are executed, still you can see that data at real time here as and when. And also you can go to the 7 days, 30 days period of executions and things like that. Not only that, you are also a time-based model, which will give you more accuracy in terms of hourly basis on how efficiently your systems are producing. Like, you have a runtime, downtime, plant time, all of them is captured here based on your production executions. Truly, it is capturing all the production execution data and representing it uniformly to the supervisor and the plant managers for them to understand what is the whole execution is happening. This helps them to understand how efficiently we are working, what is the workload, what is the slow cycle, where and how we can correct it, and if there is any need to reallocate the job to different mission, different operator to make it working, or breaking that work order into multiple jobs to execute in a different shift. So all of them can be planned based on the real-time information, which is a core lack of visibility in the systems in today. If you think about this, if you don't have this kind of facilities, then every day morning giving a job card to the operator, and they take the job card and they go and operate it. We don't know until they're reporting it. We don't know what how the quantity is produced, how long the machine is there. If the machine is down, of course I have to be physically there to see that whether the machine is down or not, until unless I get alert. So if any machine down, I wanted to get alert. I am not in the all the factory floors as a plant manager, but I want to know that what is happening in my plant, in my factories. I can set alerts in the systems based on my conditions. I can say that OE or availability or fault based on the mission. So I can get those information there. The critical assembly line informations can also be captured here, and that rules will trigger the alerts for me. So there are a lot of other functionalities. There are different ways you can use a system in a different aspect of that, from the maintenance and other things, which we can see it in a subsequent webinar. As this webinar's focus is more on the executions, so we like to focus more on the work order and job execution and how important is bill of material and things like that. And I hope that's the way that make it simple for manufacturer to come and play around with that. There's no coding, there's no technology. The system is available immediately, so they can come and start using the system. Let's go back to the one. So as we saw that, the tracking of production performance, we have different metrics, different dashboards based on how efficiently you are capturing the data, or the system is capturing the data. Then that much visibility that you can get out of your production performance. So that's a very key important piece of MES system or MOS system, to give the real-time visibility so that the planning and execution is more accurately happening. But the question is, IoT, right? So yeah, it's of course the system is good and data entries are is required, but how do we fully automate it, right? How do we make it more automated way so that we can avoid the manual data entries in the system by the operator, or how I can get the real-time information instantly in the dashboard, instead of waiting for hour or end of the shift to know my productivity. And that's where the IoT connectivity is coming into picture. You can look at this, in the factory floor. You have your machines. The machines can be connected with our IoT platform, which is the Fogwing IoT platform. That's the foundation for this whole system itself. And where you can take that machine can feed the data to our platform, that stream the data into the SFactrix system. From that, the data is being processed. At the same time, you can see the left side, the machine operator can also feed the entry into that. Both the machine data and the operator entries are consolidated together, and then the intelligence has been arrived out of that by using the inbuilt AI analytical algorithms, which helps to identify different key metrics and all. And those metrics are represented to the different user communities at the different scale. From the supervisor, plant manager, executives have a different views on that, different reports that they can look at that through our metrics that I have shown in the past. So technically, the system can be fully integrated between all the systems and get the data feed into the platform or the application, so that the system, the MES producing their more real-time data. Or if you don't have a budget of IoT, or you don't know how the IoT works, so you want to simply start with as a MES system to capture the data, you can still use the system as it is, as a software system alone. Some key things to adapt the platform MES applications. So very important thing is to get the stakeholders support. When we talk about stakeholders, not just the top management or supervisors, approval, but more like in the maintenance, the operators, the mission vendors who supporting the mission, the maintenance engineers, the suppliers, all of them has to be involved in that uniformly. So get everybody's support to streamline this manufacturing execution process with the help of the software system. So getting the all stakeholders support is critical to make this implementation or this adoption successful. Second thing is clearly define the organization structure and work hours and parts, materials, so that everything is structured properly. So each and every input is going to drive the accuracy of the system in terms of calculating the the completion time, the efficiency, and the execution metrics and that things. If possible, integrate with the ERP CRM system, so that data flow uniformly between all the system instead of having a different data in ERP, different data in CRM, and then different data in MES system. Then the total organizational data will be messed up. So having a streamlined integration helps to capture the data uniformly across the systems, including MES systems. If the MES system gets the proper material availability, the supply information, the planning, the work orders, this helps more efficiently track and plan and execute the factory floor operations. Training is very important. Provide an adequate training to your operators. The more accurately the operator feeding and executing the system on providing inputs to the system is helpful for us to more accurately measure the efficiency of the factory floor, and then taking a corrective actions on that. The last and not least, multiple machines can be consolidated into the IoT based connectors that help us to automatically feed the data into the system. So now the question is, now all in one package. So we provide as part of the product package. You can come and use our product as a software, purely software, or you can also get the help from us, and we can connect up to 5 machines using our gateways and routers to get the data from your machines and feed the data to directly into that. So we can help you to build the IoT connectivity. Of course, it depends upon your type of mission and the age of the mission and how efficiently the mission can feed some of the information. Based on that, the implementation, the IoT connectivity and timing of the implementation varies. But that is very simple to identify in early stage. If you need any consulting on that, you can definitely reach us out, and we can provide you the ideas on how you can do the IoT integration with your missions based on your mission type and age of that. With that, I'm giving back to Abhishek. If it's time for any question and answer, please feel free to throw your questions. Happy to answer it.
Thank you, Hari, for providing deeper insight on MES and the SFactrix application. So we have few questions lined up, and I was just waiting for the Q&A round. So I'm shooting the first question to you.
Mm-hmm.
How to connect with SAP or other ERP system?
We provide APIs. So if you have a team of who can connect SAP, who has a knowledge in SAP, and they can kind of take the data from SAP and feed that to our application through APIs, you can use our API interfaces. Suppose if you don't have the developers inside, if you're a small manufacturer, you don't have a developer inside. Of course, a small manufacturer may not have SAP, but if you need any technical support, then let us know, so we can also provide as part of our professional service team. They will come and implement the integration for you to connect the systems and help you to get the data from SAP to our MES system.
Okay, the next question. Which type of manufacturing business will be a better fit for SFactrix MES?
So, we, when we are design and build the system, we try to be as much as, dynamic enough to accommodate either discrete manufacturer or the process-based manufacturing companies. Either you are a food manufacturer or food production company, or you are an automotive company, still you can use a system. It depends on how you want to structure together. But mostly, I would say that it will very well fit for automotive and discrete manufacturing companies, and then moderate level fit into the process-based manufacturing companies.
Thank you, Hari. One more question. What is the duration of the implementation?
It depends on that. So simply, if we have a templates, if you are engaged with us and you want us to help you on the implementation, so we have a templates. We provide you templates. You just fill the templates, send it to us. Our team will quickly implement it. Hardly a few days, we will create a basic structure for you in the system. You can start doing yourself if you know already. It depends on how many missions, how your organization structure, size, and all. Simply, some customers just start and running in within an hour. Some of them are taking few days to start operating. Of course, configuring the system is very simple, but educating the team and start applying that is very important. That might take, depends on the size of the operating team and how they are going to adapt this, the level of skill set on that. I would say that as simple as 1 hour, within 1 hour, you can start up using the system, to all the way to 2 months period. If you are looking for a lot of integration with your existing SAP or other systems, and then you need to have the tight collaboration on that.
Okay, one more. How factory machines can connect to your SFactrix software?
So factory machines, it depends on the machines. If you have PLC systems, and you have, if the PLC system can feed the data in a proper structure to our platform, they can feed the data through our Fogwing IoT platform. So they can connect to our IoT platform and connect to that. If your PLC systems are not equipped to connect to any cloud system, you may need IoT gateway or routers that will connect with your PLC or SCADA systems to pull the data from that, and then push the data into the SFactrix system through our Fogwing IoT cloud. As I said, there are APIs also there. You can create a custom way to feed the data as well. But more interesting or more efficient approach is to deploy the routers or the IoT gateways that fetch the data in a frequency from the PLC or SCADA systems, and push the data to the Fogwing Cloud, through which it can reach the SFactrix application.
Thank you, Hari, for the answers. So far, these are the questions that I've received. Guys, any more questions? I think we are exceeding the time as well. So, guys, I think it is time to wind up this session. And if you have any questions, this webinar video will be available in our YouTube channel. You can visit our YouTube channel tomorrow and then take a look at the video. Also, can post your questions there, and we'll be responding to the questions. Hari, so I think we can wind up.
Oh, fantastic! Thank you so much. Thanks everyone for your time, and taking time to watch this this webinar. I hope it's useful, and you should definitely try it out in our systems and experiment it for your manufacturing use cases. If you have any questions, please feel free to reach us. We are happy to help you on that. And thank you so much again. Have a nice day, and looking forward to see you in the next webinar.
Thank you so much, folks. Have a nice day.